Hello. So today is a little different. We're obviously doing notes via video. So all of these things you are responsible to know, and you can rewatch the video if you get lost or if you're kind of stuck on something. But we'll go over some of these in class as well. So just let me know if you have any questions. But here are 3 different formulas that you will have to have memorized for our test. And this one shouldn't be new to us, but these 2 might be a little new. The one thing I want to note for these is that this says 1/2 D1, D2. These D's, both of them, stand for diagonal. Okay, so it's the whole length of the diagonal if it's a rhombus or a kite. And then here we have 1/2 times height times base 1 plus base 2. And just as a reminder, the bases are the parallel sides. Okay, these are the parallel sides. And last but not least, before we move into this, just as a note, the base and height of any of these shapes are always perpendicular, which means that they form a right angle. Okay, so whenever you're looking for the base and height, they have to form a right angle. Okay, so let's take a look at number 1. It says find the area of each quadrilateral below. Taking a look, we can notice that this is a parallelogram since the sides are different here. It's not a rhombus, but parallelogram, which if you look above means we're going to be using base times height. So if we know our area is base times height, we have to figure out which one's the base, which one's the height. And like we said, base and height are perpendicular, which means that we will be using 18 as the base and 16 as the height. So we substitute them into our equation. 18 times 16, which should give us 288 feet squared. Units are always squared when we're talking about area. Okay, take a look at number 2. All the sides are the same, so that means it's either a square or a rhombus. But since we're given the sides, we can use base times height again. If we were given both diagonals, we could be using 1/2 D1, D2. But we could use base and height, and in this case, it's a square because we have a right angle, so both of these are the base and height. So that just gives us equals 1.6 times 1.6, which I believe is 2.56 centimeters squared. All right, hopefully you're tracking with me so far. Taking a look at number 3, I'd like you to pause the video and try it out on your own. So give yourself a minute, try it out. Now, if you tried it, you should see it's still a parallelogram. Our equation is still base times height. But in this case, our base is going to be 8 and our height is 12. Because if you notice, these 2 sides have to be the same. It's parallelogram. And 12 is the side that forms a right angle with 8. So we are going to be using the sides of 8 times 12 to get our area. So if you put 80, I would be careful and make sure that you have 8 times 12, which is 96 millimeters squared. Okay, moving right along, we can take a look at this next shape, which we should notice is a trapezoid, which means we're using the formula from above, 1/2 times height times base 1 plus base 2. And looking at this trapezoid, we should know that the parallel sides are the bases, which in this case, it's these 2 sides. Now, it doesn't matter which one we label as base 1 and base 2, because when you add, the order does not matter. So let's just say for our sake, we label this one as base 1 and this is base 2. But now let's figure out which one's the height. Well, like we said, the height always forms a right angle with the base, so that would mean that 16 is our height. So once we do that, we can substitute everything into our equation. 18 plus 32. When you substitute all that in, you can go ahead and put that in your calculator. I believe you should get 400. And we don't have units, but this time we could just say u squared for units squared. Okay, so then for number 5, if you look, all of these pieces have these markings, which means that they are all the same, which means they're all 4. So we can go ahead and put 4 there. And, what shape is this? If all of the diagonal pieces are the same and they bisect each other, that means it must be either a rectangle or a square. So using what we know, if we know it's either a rectangle or a square, we can use this rhombus formula because a square is a rhombus. So if we do that, that would be area is 1/2 times diagonal 1 times diagonal 2. So we have to figure out what is the length of diagonal 1. Well, again, it doesn't necessarily matter which one comes first, but if we call that one diagonal 1, we could add together 4 and 4 to get us 8. And diagonal 2, it happens to be the same thing if you add these two pieces together. So that gives us 8. So when we go to substitute it into our equation, 1/2 times 8 times 8, we should get 32 meters squared. Okay, next one we have a kite. So it's our same equation as we used for number 5, 1/2 diagonal 1 times diagonal 2. So this time our diagonals to find them is a little more tricky, but it's still the same process. Let's say we call this one diagonal 1, and again, it doesn't matter which one we call 1 or 2, but this one will have 4 plus 4, giving us 8. And the other one, let's add this whole diagonal together, which is 2 plus 6.5, which gives us 8.5. So when we substitute D1 and D2 into our equation, we'll have 1/2 times 8 times 8.5. So when you substitute that in, you should get 34 feet squared. Okay. Hopefully you're pausing the video to calculate these yourself, because putting them in your calculator is a skill. So, taking a look at 7, this isn't a kite, this isn't a rhombus or a parallelogram, this is a trapezoid. So we're back to using our formula for 1/2 height times base 1 plus base 2 for the area. So looking at this, bases are parallel, so we can call this one base 1, and this whole thing is base 2, not just 8, the whole entire thing. And then 4 would be our height because it makes the right angle with the base. So we have to figure out what this missing piece is first to help us find base 2. So if you notice, we have this right triangle here. Oh, I'll redraw that. We have this right triangle here, and we know 2 sides of it. We need to find the third side. So to do that, we need to use Pythagorean theorem, which is a squared plus b squared equals c squared. So 7 is our c because it's across from our right angle. So we'll have x squared plus 4 squared equals 7 squared. So x squared plus 16 equals 49. So x squared equals 33. So you take the square root. So x will equal 5.74, which means this little piece is 5.74. So to get our whole base 2, we'll have to add 8 plus 5.74 to give us 13.74. So when we substitute everything into our equation, we'll have 1/2 times 4 is our height, times base 1 is 6, plus base 2 is 13.74. And take a moment, plug this all into your calculator. So pause the video, plug that all into your calculator. You should get 39.48. And again, we don't have units, so we can just say u squared for unit squared. Next one is a kite, as you can see, which means our diagonals are perpendicular. And we know the longer diagonal cuts the shorter diagonal in half. So if this one is 6, that means this one over here has to be 6 meters. But to find the area, we need to figure out what this is, because that's part of our diagonal here. Well, once again, we have a right triangle. We know two sides, we're missing the third side. So go ahead, use Pythagorean theorem. Pause the video, use Pythagorean theorem to try to find x. Hopefully you got 8 meters there. So now we can figure out what each diagonal is. So if we use this as diagonal 1, 6 plus 6 is 12. Diagonal 2, it's 8 plus 9 is 17. So when we substitute into our equation of 1/2 d1 d2, area equals, we'll have 1/2 times 12 times 17, which is 102 meters squared. Okay. Taking a look at 9, we again have a trapezoid. Label your bases B1, the whole thing, 20. This is nice, it gave us the whole thing. But this time we're missing the height. We don't know what it is, but we have this right triangle here. This time we don't know two sides, but it gave us this 45-degree angle, which means that we can use either trig or special rights using this as our hypotenuse to figure that out. Now, for this one, let's use special rights since we know 45, 45, 90 is oh so well. So when we label L, L, L root 2, these are in the same spot, so that means they're equal to each other. So let's set 12 equal to L root 2, divide by root 2, divide by root 2, because you need to get L by itself. So we have L equals 12 over root 2, but we don't want a square root in the denominator, so we multiply top and bottom by root 2. So that gives us 12 root 2 over 2, which is 6 root 2. That means our L is equal to 6 root 2, which is our height. So we can use our equation 1/2 times height times base 1 plus base 2 for a trapezoid. So when we substitute everything in, we'll have 1/2 times 6 root 2 times 8 plus 20. And to keep it exact, we're going to put everything but the square root in our calculator. So what that is going to look like is 1/2 times 6 times 28. So that is going to be 84 root 2 millimeters squared. Okay, hopefully you can put that in your calculator, but make sure you don't put that square root in. Okay, we have two more that we're going to do together. I'm going to have you try 11 on your own. But taking a look, this is a rhombus. If we had our diagonals, we could use 1/2 d1 d2, but we don't. So we need to use our equation for a rhombus of base times height. It gives us this here. I'm going to draw it in over here, so you should do that as well. And notice how it creates this right triangle with 30, 60, 90. So you have this angle. You know this side is 24 because it's a rhombus. All sides are congruent. Go ahead, try to find your height. Use 30, 60, 90 to find your height. You should have your height is 12 root 3. When you label with S, 2S, and S root 3, your base is 12, so your area is going to be 24 times 12 root 3. When you multiply 24 and 12, you get 288 root 3 inches squared. I want you to try this same thing with this one, and we'll come together with the answer in a minute. So pause the video, try this out. Alright, so hopefully you tried it out and you got 300 root 3. If not, you can pause the video and take a look at all the notes to try to figure out what went wrong. Last but not least, number 12. This is a hexagon. It has 6 sides, which means when you draw on the diagonals, you end up with 6 equilateral triangles. So as a reminder, the area formula for a triangle is 1/2 base times height, or base times height divided by 2. Here I gave you the base and the height, so it's just 1/2 base times height, but there are 6 triangles, so you have to multiply that by 6. Go ahead, put that on your calculator to figure out what that should be. You should get 261 inches squared. Now on the back, I'd like you to draw your pictures and try those out. Good luck!